In this system of equations, I've rewritten them so there's one on top of the other. And we're going to be looking for no decimals, fully reduced fractions, and radicals. As I look at it up one on top of the other, I can see that we have 1y squared and 1y squared, and if I got one of them negative, I could eliminate very easily. So I'm going to make the top equation negative by multiplying every term by -1, and I get a positive x, a minus y squared equals -4. And now I can add these two equations where the bottom equation came from the top. So as I add, notice this x squared and this x are not like terms, and I'm going to have x squared plus x. The y squareds cancel out, and 4 plus a -4 is 0. And so now hopefully you can see that this can be factored. I can factor an x out, and I'm going to have x plus 1 equals 0. Only x times x is x squared, and x times 1 is x. That means my values of x are 0 and -1. So if I start thinking about ordered pairs, I know I'll have 0 comma something and -1 comma something. And it's possible there'll be two answers for y, but now at least I know what the x values are. I'll take either of the two equations, doesn't matter. But as I look at this top equation, it's somewhat simpler as there's no x squared. So I have -x plus y squared equals 4. And for this x, I can plug in a 0. So that results in y squared equals 4. Taking the square root of both sides, I'm going to have a plus and -2. So that means for here I have 0, 2, and I also have 0, -2. Then I'll look at when x is -1. -x plus y squared equals 4. And in this x, I plug in -1, so I really have negative of negative, or 1, plus y squared equals 4. Subtracting 1 from both sides, y squared equals 3. Taking the square root of both sides, y equals plus and minus square root of 3. So sure enough, there's going to be two answers for this one as well. Square root of 3. And that same -1 goes with negative square root of 3. These are the 4 correct answers for this problem.